Welcome to the Deep Dive. Today, we're looking at some really compelling research into brain science. Our mission is simple: unpack the single most astonishing truth inside it all, which is that your mind isn't some static machine. It's more like a living, growing sculpture. And we're jumping straight in with a finding that honestly is revolutionary. It comes from maybe the most chaotic, historic city out there, London. You know, if you hold a human brain, it's about, what, 1.4 kilograms, just this gelatinous tissue. And for centuries, the scientific thinking, the dogma really, was that once you're an adult, your brain's physical structure is pretty much set, fixed.
Right. That was the prevailing wisdom for a very long time. Adult brain equals static structure.
But imagine a mental task so incredibly tough, so monumentally complex, that just doing it for a few years could literally force that 1.4 kilos of tissue to physically change, to expand its actual architecture. That's what we're diving into today. The stunning, verifiable physical transformation happening inside the heads of London's legendary taxi drivers.
Yeah, it's become this classic example, really, the ultimate proof of neuroplasticity. But not from lab rats, you know? It's from real people navigating intense real-world complexity. Before this research came out, many scientists assumed that kind of major brain rewiring, well, that was mostly for kids during development or maybe adults recovering from a brain injury. These findings just showed so elegantly, with actual anatomical proof, that the vast network inside your skull, that universe of connections, is constantly negotiating. It's growing, adapting, all based on what you ask it to do.
Okay, so we've got this radical idea.
Yeah.
The physical brain changes with extreme learning. But what kind of mental effort are we talking about? What challenge is so huge it forces the body to build, well, new brain bits?
We are talking about the knowledge.
Ah, yes, the knowledge. If you haven't heard of it, this isn't just like passing a driving test. It's something else entirely. To get that famous green badge, to drive one of London's black cabs, you have to conquer what basically a cognitive Everest. It's unique globally in its difficulty.
It really is.
So let's get specific. You have to memorize perfectly, or near perfectly, the layout of 25,000 streets.
25,000. Within a 6-mile radius of Charing Cross, the traditional center point.
And that's not even all of it, is it?
Not even close. You also need to internalize thousands of landmarks. Think every tiny theater, obscure restaurants, embassies, hidden little muse streets, and crucially, the most efficient routes between any 2 points in that massive area.
The sheer scale, it's hard to grasp.
It is. People estimate the number of possible routes a driver needs to be able to figure out, on the fly, is in the tens of thousands, maybe hundreds of thousands. And the average person trying this spends, 3 or 4 years, often just riding around London on a moped day after day.
With maps or index cards?
Yeah.
Just constantly building this incredibly detailed mental map.
Yeah, building that mental atlas.
It just sounds like such a brutal commitment. And the sources we looked at really highlight the human side of it. The failure rate is incredibly high.
Oh, absolutely. Most people who start the knowledge don't actually finish it.
It's like a pilgrimage, isn't it? Years of just solitary, grinding mental effort. Friction.
And that friction, that's the key word, because they aren't just memorizing a list or following a line on a GPS. That's passive. They're internalizing the entire structure of the city. It's one-way systems, it's weird historical quirks, the traffic bottlenecks, how everything changes depending on the time of day.
Yeah.
It becomes this dynamic, predictive, almost three-dimensional spatial intelligence.
So when someone gets in the cab and says, "Take me from the British Museum to, I don't know, some specific doctor's office in Kensington,"
the driver doesn't look it up. They simulate it instantly. They run mental models of the fastest route, weaving together all these different data points in real time.
the difference is huge. One is just retrieval, like looking up a fact. The other is, well, it's fluid, dynamic thinking. Spatial reasoning on a whole other level.
Exactly. And it was the sustained, intense mental demand that caught the eye of neuroscientist Eleanor Maguire and her team back at University College London. This was around the early 2000s.
Right, and their question was pretty radical then, wasn't it?
Yeah, very much so. They asked, could this extreme mastery of space, this intense learning, actually physically alter the brain structure of these otherwise normal, healthy adults?
So the experiment, they brought in the taxi drivers. And a control group, right? People who didn't drive taxis.
That's right, matched controls. And they put them all into structural MRI scanners.
And this is where things got really interesting, where neuroscience kind of shifted.
Precisely. The results, they published them in a major journal, PNAS, back in 2000, and it delivered the proof, the undeniable proof that the adult brain is malleable, plastic.
Okay, so what was the big finding?
The team found a really striking, measurable difference in anatomy. The back part, the posterior section of the hippocampus in the taxi drivers,
Yeah.
it was significantly larger, bigger than in the control subjects.
Okay, let's pause there. The hippocampus. Why is that structure so important here?
Well, the hippocampus is arguably the brain's headquarters for memory and navigation. It's deep inside the temporal lobe, kind of shaped like a seahorse, actually.
Right, I've heard that comparison.
And the posterior part, the tail end of that seahorse, if you like, seems specifically involved in creating and using these big, detailed cognitive maps of space. It's like the brain's built-in GPS hardware.
So you're saying, because the drivers were constantly, relentlessly using that specific bit of hardware day in, day out for years.
Oh, it literally bulked up.
Yeah.
Like a muscle you exercise consistently.
Like a bodybuilder's bicep getting bigger from lifting weights.
Exactly that analogy. The actual gray matter, the neural infrastructure supporting all those connections for spatial mapping, it increased in volume to meet that extreme demand.
Wow.
And what's really fascinating is that it wasn't just a snapshot. The research showed this change correlated with experience.
How so?
The amount the hippocampus had grown was directly linked to how long the driver had been on the job. So a veteran cabbie with maybe 20 years navigating London showed more physical expansion in that area than someone who just passed the knowledge.
So there's a literal physical growth curve tracking their mental experience over time.
Precisely. It's quite extraordinary when you think about it.
Okay, now, if the story just ended there, right, if it was simply use it and it grows, that would be amazing enough. But the work Maguire's team did uncovered something even more nuanced, maybe even more thought-provoking. It wasn't just growth across the board.
That's right. And this connects to a bigger idea in brain science, something called competitive plasticity. While that posterior, the spatial part of the hippocampus, had expanded significantly, the researchers found something else, a related finding. The anterior hippocampus, the front part, was actually slightly smaller in the taxi drivers compared to the controls.
Smaller. So wait, one part gets bigger, another part gets smaller. So the brain isn't like an infinite hard drive where you just keep adding more memory indefinitely. It's more like it's reallocating resources, shifting things around.
That's exactly the interpretation. It looks like, faced with this overwhelming, years-long demand for spatial mapping skills, the brain prioritized. It shifted its neural real estate, you could say. It engaged in a kind of subtle neural Darwinism, pouring energy and structure into the skill that was absolutely essential for their job, for their survival in that context. And perhaps that came at a very subtle cost to other functions handled more by that anterior region.
Okay, so what does the anterior, the front part of the hippocampus, usually do? What was potentially getting less real estate?
Well, the anterior part is generally more linked with encoding new memories that aren't spatial. Associative memories. Think about learning arbitrary pairs, like remembering a new person's face and linking it to their name, or memorizing a list of unrelated facts for a test.
Ah, okay, I can see the potential trade-off there. For a cabbie, being able to instantly recall and manipulate that vast spatial map is way more critical day to day than maybe quickly memorizing the name of someone they just met briefly.
Exactly, that's the hypothesis. And later studies did look into the behavioral side of this. They suggested that while these drivers were absolute champions at navigating physical space, they were perhaps slightly slower on average when it came to acquiring those specific types of new associative memories.
So their minds became these incredibly specialized tools, sharpened, honed for one primary, super high demand job.
Yes. Which, raises an interesting question for all of us, for you listening. If your brain is constantly making choices about where to invest its energy, where are you pushing it to specialize? What skills are you prioritizing?
That's a good point.
But the big takeaway, the universal lesson that goes way beyond London streets, is the principle this study proved so powerfully: neuroplasticity. It's the brain's fundamental ability to reorganize itself physically, structurally, by forming new neural connections throughout your entire life based on what you learn and experience.
So that old idea of the brain being like a fixed circuit board after childhood,
Yeah.
just obsolete.
Completely obsolete. A better analogy, maybe, is thinking of your brain like a living forest. Malleable. Every time you consciously push yourself to learn something new or challenging, whether it's a language, a complex game, or mapping a city, you're essentially walking down a little dirt track in that forest. Keep using that track, keep putting in the effort, and eventually it gets wider, smoother, more established. It becomes a paved highway, fast and efficient.
I like that highway image. You can almost feel the mental effort involved. Every time that driver has to figure out a detour for road closures or plan a route between two really obscure points, those neurons are firing together in complex patterns.
Oh.
Over and over.
And that consistent, challenging stimulation is the workout. It's the physical stress that causes the anatomical change, the growth that we can actually see on an MRI scan.
And this isn't just about taxi drivers, is it? This is happening everywhere, in different ways.
Oh, absolutely. The London cabbie study is just such a clear, magnified example because the task is so demanding and so specific. But we see similar principles at play elsewhere. Think about professional musicians like violinists. Studies show the area of their sensory cortex dedicated to the fingers of their left hand, the one doing all the complex, rapid fingerings, that area is physically larger than in non-musicians.
Ah, interesting. More neural real estate for the demanding skill.
Exactly. We even see measurable changes in the hippocampus of medical students after relatively short, intense periods of studying for exams. Their brains adapt quickly to the demand.
So whether you're trying to master, say, Mandarin or learn a really complex bit of code, or even just get good at a tricky board game,
You're engaging that same fundamental process, the one that physically expanded the brains of those London drivers. You are literally building a bigger, more capable, more intricate landscape inside your own head.
Okay, let's bring this back home. Why does this amazing feat of memory, mastering the knowledge, why does it even matter now? We all have GPS on our phones, right? Turn-by-turn directions are instant.
Well, yeah, that's true for navigation, but I think it matters because of what the process does to the person. The journey of learning, it changes the learner, the pilgrim. The driver who spends years mastering the knowledge doesn't just know routes, they understand the city, its logic, its history, its pulse.
Whereas the GPS user,
Yeah.
they're just following a line, an algorithm's instruction.
Exactly. For the driver, that deep, hard-won knowledge of London isn't just data in their head, it's etched into the physical structure, the very fabric of their hippocampus. There's a deeper understanding.
That physical change, then, it serves as this powerful metaphor for all of us.
I think so. It tells us that your brain isn't some fixed prison, defined only by the talents you think you were born with, or the limits you assume you have. It's more like a living sculpture, and it's being shaped constantly, daily, by the choices you make, what you decide to learn, what you choose to focus on, the challenges you decide to take on.
So maybe the next time you're really struggling to learn something new, that feeling of mental friction, the frustration when something feels unfamiliar or difficult.
Yeah.
Maybe remember the London taxi driver. Remember that struggle, that difficulty, it isn't just frustration. It's actually evidence. It's the feeling of that silent physical expansion taking place inside your skull.
That's a great way to put it.
The discomfort means you're building something. You're carving out a more intricate, a more capable landscape within your own mind. And maybe that feeling is something worth pushing through for.